Sketch the graph of y equals x to the power of 4 minus x cubed minus 13x squared plus x plus 12, clearly labelling all axial intercepts and turning points with their coordinates. When necessary, give the coordinates correct to 2 decimal places. On the CAS calculator, go into the main menu. Next, what we want to do is type in the equation of the chordic that we want to graph. So we want to type in x to the power of 4 minus x to the power of 3 minus 13x to the power of 2 plus x plus 12. Then we can click the graph button and that will bring up this screen, and highlighting our equation and dragging it over the graph screen will graph the chordic equation. Next we can press the resize button, and now we want to adjust the graph screen so that all the key features are shown. So you may need to do a bit of trial and error for this. So clicking on the 4 arrows, we can set the minimum and maximum x values. So I'm going to leave these as negative 7.7 and 7.7. And I'm just going to adjust the y values. So for the minimum y value, I'm going to put in minus 60. And for the y maximum, I'm going to put in 20. Pressing OK will now show the chordic equation, and we can see that all of the key features are present. If we go analysis G-solve, we can use root to find all of the x-intercepts. So the first one is at negative 3, 0, and hitting execute will lock that on the graph. We can then press the right arrow on the hard keypad to go across to the next x-intercept, and then press execute, and that will be locked on. Pressing right again, we can lock that on, and pressing right again, we can lock the fourth x-intercept in. Next, we can go analysis G-solve minimum, and we can find the minimum turning points of this graph. So pressing execute will lock that on, and clicking the right button will get the next minimum. And again, pressing execute will lock that coordinate. We can then go analysis G-solve, and we can click max, and that will give us the maximum turning point, and we can lock that onto the graph. And finally, and this is where this example you need to be careful, this maximum turning point isn't the y-intercept, even though it may look like it. We can go analysis G-solve y-intercept to find the value of the y-intercept. So now we have all key features of the graph with their coordinates. Our job now is to sketch the graph from the calculator screen. So it's going to look a little bit like this. Next, we need to label all the key features with their coordinates. So this was an x-intercept at minus 3, 0. This x-intercept was at minus 1, 0. This x-intercept was at 1, 0. And finally, this x-intercept was at 4, 0. The two local minimums down here were at negative 2.22, negative 19.06. And the other one here was at positive 2.96, negative 48.13. And finally, it got a little bit tricky around this turning point up here, which is a local maximum. We had the y-intercept being at 0, 12, and the turning point, just slightly on the positive side of the y-axis, was at 0.04, 12.02. So again, it may have looked like the turning point and the y-intercept were the same point, but when we went analysis G-solve and found those two features, they weren't the same. So you need to be really careful that you don't assume something about a graph and that you actually check it.